Hello everyone, welcome to the ITLS Academy. Today we are going to discuss another lecture in the series of FSSAI water analysis, and the topic that we are going to discuss is a determination of the sodium, and the method that we are going to use is a flame photometric method. Okay, so we all know that sodium is what? Sodium is a compound which is used to detect the quality of the water. Okay, suppose that if this concentration of the sodium is higher in a water, then obviously when we drink that water, uh, ultimately the concentration of sodium will higher in our body. Okay, and for our safety, it is not recommended that the concentration of the sodium will be higher in our bloodstream. Okay, that's why it is very important to detect it. Okay, so this quality this sodium is determine the quality of the water, determine the quality of the water for both, like for human consumption and along with industrial use. We cannot use a higher concentration of sodium in a industry. Okay, that's why when we are when we are determine the sodium, so it is very important. Now for the determination of sodium, the method that we are going to use is a flame photometric method. Okay, so let's start the today's lecture and come to the first slide, that is your introduction slide. Introduction. Sodium ranked sixth among the element in order of abundance. Okay, so this sodium are abundance presence. Presence are what? Their presence are abundance. Okay, and it comes at a sixth rank in an element. Sodium have a sixth rank in their abundance, and it is present in a natural water. Okay, so natural water, the concentration of the sodium are very high. This level may vary from less than 1 milligram sodium per liter to more than 500 milligram sodium per liter. Okay, so their concentration are vary in a natural water. If we take a natural water, okay, if we take a natural water, then the concentration of the sodium are vary from 1 milligram of sodium per liter to 500 milligram sodium per liter. Relatively high concentration may be found in brines and hard water softened by the sodium exchange process. Okay, so the concentration of the sodium are high in a brine water, like your sea water, because it will consider as a what? It will consider as a hard water which are softened by the sodium exchange process. In both type, like hard water which are softened by the sodium exchange process, and the brine water, the concentration of the sodium are very high. Now next, the ratio of the sodium of total cation is very important in agriculture and human pathology, that I already told you. The concentration of this sodium, the concentration of this sodium are very important in both, like in agriculture and in human pathology. Now soil and permeability can be harmed by high sodium ratio. Persons afflicted with certain disease required water with low sodium concentration, and limited concentration of 2 to 3 milligram per liter, which is recommended in feed water destined for high pressure boiler. In necessary, sodium can be removed by hydrogen exchange process or by a distillation. Okay, so if we want to remove the sodium, then we can remove it with the help of the hydrogen exchange process or either by the distillation process. Now this sodium compound are used in many applications like caustic soda, sand fertilizer and water treatment chemicals. In all these cases, the sodium compound are very important. But if we talk about our human, then the concentration of the sodium are sometimes it is very harmful, like maybe it increases the blood pressure and some other disease also related to the higher concentration of the sodium. That's why it is very important to determine the sodium. Now, scope. The standard are prescribed method for the determination of the sodium by flame emission photometric method using a flame photometry method. Okay, so the method that we are going to use is what? It is a flame emission photometric method, and in this method we are using a what? We are using a flame photometry method. This is the scope of this experiment. Now come to the next slide, that is sampling and storage. Now what we have to do, we have a sample. Okay, now when we have a sample, now what we have to do, we acidify it this with the help of concentrated nitric acid. Suppose that when we take a sample and measure its pH, it will be around 7.2. Now what we have to do, we acidify this sample by adding the concentrated nitric acid, and then we lower the pH of this sample, and then it reaches to a 2. Then after that we store that sample in a polyethylene bottles. Then we store the sample in a polyethylene bottles. Okay, so but before storage, what you have to do, you have to acidify your sample with the help of the concentrated nitric acid, and the pH will reaches 2. It is very important. Now the next is the principle. A flame photometer measure photoelectrically the intensity of the color imparted to the flame of Meeker type burner. Okay, the flame photometer measure photoelectrically intensity of the color imparted to the flame of a Meeker type burner, where the sample is introduced into the flame under a careful standardized condition. When the intensity of the color is proportional to the sodium content in the sample, then sodium is determined at the wavelength of 589 nanometer. Then with the help of the spectrophotometer, we take a wavelength at 589 nanometer. Okay. Now, after principle, come to the next slide. That is your interference. So, interference are what? Interference which causes error. Which causes error. Suppose that when we are performing the experiment, so due to that material, we don't get a correct result. It alter our result. That is called a interference. So radiation interference caused by element other than those being determined is the chief contributing factor for error in a flame photometry. Okay, so there is a radiation interference are caused, and this radius interference are caused by the elements which are not involved in the determination of the chief contributing factor, and when we are performing the flame photometry. Of the elements encountered in these analysis, the major effect is due to the interference of one alkali metal on another. Some effects are positive and some are negative. Among the other common ion capable of causing interference, that is your calcium ion, SO4 2 negative, HCO3 negative, they are what they, when they are present in a highly concentration, then it will interfere in our experiment. So what we have to do, we have to remove these interference by performing the experiment. Then after that, we have to perform our experiment so that it will not alter our result. Okay, now come to the next slide. There are several foreign elements are also present which effect cannot be internally compensated without employing the calibration standards, closely duplicating the composition of the sample, or by applying and experimentally determine the correction in those instances where that sample contain a single important interference. However, the effect may be minimized by operating at the lowest practical sodium concentration range, or sometimes by removal of that interfering elements, like your aluminum, which have a depressing effect on alkali metal emission, and it can also causes a serious consequences. Okay, so these are what? These are the interference which affected our experiments. Now, come to the next slide. Suspended matter which may interfere mechanically by clogging the burner shall be removed by the filtration prior to the analysis. So there are lots of suspended matter are present which interfere mechanically. Okay, how they interfere? They clog the burner shell. So we can remove that suspended matter by the filtration before starting our analysis. Organic coloring matter does not cause interference and need not to be removed. Okay, so if there is organic coloring matter are present, then it does not cause any interference, so we don't require to remove it. Now, flame photometer operating on the internal standard principle, it may require adding a standard lithium solution to each working standard and sample. Follow the manufacturer instruction for optimum lithium concentration. Incorporate a non-ionic detergent in the standard lithium solution so that we will ensure that the aspirator are in a proper functioning or not when we are using our internal standard type flame photometer. Now, the next is your apparatus. So, flame photometry is an apparatus which we use for performing this experiment. So, either they are direct reading flame photometer we will be used, or either our internal standard type or atomic absorption spectrophotometer in a flame emission mode will be used for performing this experiment. Now, the next is your glassware. So, we will use a common glassware like your conical flask, beaker, or your measuring cylinder. These are what? These are the common type of the glassware we will use. Okay, but these glassware should be rinsed with the help of the diluted nitric acid, and it will be diluted in the ratio of 1:15, which means that if we take a 1 ml of the nitric acid, then we will add 15 ml of the distilled water. Okay, it should be rinsed. These glassware should be rinsed with the help of that uh, diluted nitric acid, which is followed by a several portion of the deionized distilled water. Okay, so these are the glassware that we use for performing the experiment. Okay, now come to the next slide. That is your reagent. So for the preparation of the reagent, what we have to do, first of all, we have to use a deionized distilled water. Okay, we cannot use only distilled water, but in the place of the distilled water, we have to use a deionized distilled water, and it should be calibrated standard at dilution water. Okay, so either we are preparing the reagent, either we are calibrating the pH meter, either we are preparing the standard solution, either we are dilution with the help of the water. In all the cases, we should use a deionized distilled water in the place of the distilled water. So first of all, we have to prepare the stock of the sodium solution. For this, what we have to do, we take a 2.542 gram of the sodium chloride, and it should be dry at hot air oven for 1 hour at 140 degrees Celsius. After that, we dissolve it into a 200 ml of the deionized distilled water. Then after that, when it is completely dissolved, then we will add the remaining 800 ml of the deionized distilled water and make up 100 ml. Here 1 ml is equal to 1 milligram of the sodium. This is how we prepare the stock of the sodium solution. Now come to the next. Now, after preparing a sodium solution, we have to prepare a standard lithium solution. For this, what we have to do, we have to require a 6.109 gram of the lithium chloride or 9.93 gram of the lithium nitrate. Both can be used. Either you can use a lithium chloride or either you can use a lithium nitrate. But when you are using a lithium chloride, you have to take 6.109 gram, and if you are using a lithium nitrate, then you have to take 9.93 gram. Then after that, you have to dry it overnight at hot air oven, and the temperature of the hot air oven will be 105 degrees Celsius. Now after that, you have to dissolve this into a 200 ml of the distilled water. When it is completely dissolved, then add a remaining 8 ml of the deionized distilled water. Not only distilled water, it will be a deionized distilled water, and make up volume 1000 ml. Here 1 ml is equal to 1 milligram of the lithium. Note down, prepare a new calibration curve whenever a standard lithium solution is changed. Okay, now the next is procedure. Direct intensity measure. For this, what we have to do, first of all, we have to prepare a blank and sodium standard in stipend amount by diluting the stock solution described in above for any of the following applicable range, that is your 0 to 10 milligram per liter, 0 to 10 milligram, 0 to 100 milligram per liter, so that within each range there are equally spaced standard in tenth of the maximum. Starting with the highest calibration standard and working towards the most diluted standard, measure emission at 589 nanometer for a sodium in a spectrophotometer. Okay, then repeat that operation with both calibration standard and sample, which are enough number of times so that we will secure a reliable average reading for each solution. Okay, so what we have to do, we repeat the operation for both the calibration standard and for sample, so that we will get what? We will get a average reading. Then we construct a calibration curve by plotting our emission intensity scale reading versus concentration of each calibration standard on a linear graph paper. Then after that, we will determine that concentration of the sodium in a sample solution from a respective calibration curve. Then internal standard measurement. For this, what we have to do, we take add a appropriate amount of standard lithium solution for the carefully measurement volume of sample, each sodium calibration standard and the black, and then follow all the steps described above that we already discussed. Then after that, we come to the calculation part. For both direct intensity measurement or a internal standard measurement, the sodium amount of sodium is equal to sodium in milligram per liter in portion multiplied by D. D is what? D is a dilution ratio. So this is how you calculate the concentration of the sodium, or this is all about the determination of the sodium by this method. I hope you will understand, but if you have any query related to this experiment, you are free to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also visit our website, that is www.itlsacademy.com, or ask your query to the helpline number that are already mentioned in your slide, that is 7080833450. Thank you for watching. Please like, share and subscribe our channel.